Welcome to our new unit on dilations, similarity, and introducing slope. This is Lesson 1, Sketchy Dilations, Exploring Dilations and Similarity. And in this lesson, you'll know what it means for two figures to be similar. Let's get started. In your workbook, we're on page 63. And our goal is to know what it means for two figures to be similar. Know what it means for two figures to be similar. In order to understand that, we need to understand two words or two phrases. One is what a dilation is, and one is what exactly are similar figures, since that's part of our learning target. Let's start with what a dilation is. You saw a lot of those in the activity on Desmos today, and it's a new kind of transformation. I should tell you to write small. A transformation in which each point on a figure moves along a line and changes its distance from a fixed point. Moves along a line and changes its distance from a fixed point. Changes its distance from a fixed point. Okay, let me show you what I mean with an example here. I'm going to make that fixed point right here, and that fixed point is called a center of dilation. And I'm going to make two figures. I'm going to make a pre-image and an image. And I'm going to try and do a good job at this. Each point on a figure moves along a line, that's going to be my ruler, and changes its distance from a fixed point. So there's my fixed point. I'm going to start by making one point on my figure 1 centimeter away from that fixed point. And the next one, I'm going to make, I might be sorry I did this, 3 times as far, 3 centimeters away. Actually, I'm going to make that other one in a different color because that's going to be my image. That's going to be my pre-image. That's going to be my image. I'm going to do it again. I'm going to make the corners of my figure. Let's see, this time, might be sorry. I'm going to make my first point 2 units away, or 2 centimeters away, and my next one 3 times as far. That's 6 centimeters away. I keep meaning to do this in pink. Okay, that's my image. And I'm going to make one more point to make a triangle. And this time I'm going to go, let's see, I did 2 before. Let's do 1.5 somehow. Good. You got to make sure it fits on here. Oh, it's going to be a goofy figure. I've got a figure, or a point that's 1.5, and if I multiply that by 3, 3 times as far would be 4.5. So I've made 3 points to make a triangle. It's kind of a goofy triangle, but bear with me. It's a really fat triangle. I'm going to call this point A, B, and C. And because I used the same scale factor, all of these points on the other triangle are 3 times the distance along that ruler as the original pre-image points were. So these are similar figures, or this is a dilation. A prime, B prime, C prime. I'm just going to go back one more time and visit this definition again. We have the transformation in which each point on a figure moves along a line. Here's the point on my figure, and I'm just going to continue that line until I get here, and changes its distance from a fixed point. Again, that fixed point is our center of dilation. All of these pink dots are 3 times the distance from my fixed image as the original green dots. And that's a dilation. So some facts and characteristics I mentioned a little bit. That fixed point is called the center of dilation. We'll be talking a lot about that center of dilation when we talk about descriptions of dilations. And all those original distances from that fixed point to the pre-image, all the original distances are multiplied by the same scale factor. Every time I multiplied those distances by 3. All the original distances are multiplied by the same scale factor. We'll talk more about scale factors moving forward. And for something that's not an example, if I have a pre-image that's a right triangle and an image that I'm trying to say is not a right triangle, that's not going to be similar. In fact, if I tried to line these back up and connect them back up to some kind of center of dilation, they wouldn't do it. When I do this with corresponding vertices, these 3 lines should intersect, and they don't. They don't all intersect in the same point. Those aren't similar. So that's what a dilation is. There's a center of dilation that I can stretch out to make a figure that's the same shape but a different size. We've created some similar figures. Let's go into what similar figures actually are. 2 figures are similar. 2 figures are similar if one can fit exactly over the other. One can fit exactly over the other. And so far, this sounds like just any kind of rigid transformation. But we're going to allow for one more thing with similar figures, not just rotations, reflections, and translations, but also this new transformation that we just discussed, a dilation. Fit exactly over the other after rigid transformations and dilations. After rigid transformations and dilations for similar. Let me see if I can show you what I mean. It's going to be a little tricky to draw my example, but I'm going to draw a triangle ABC. I'm going to try and make it a right triangle. I could rotate this, pivot it here on point A, and bring this right angle down a little bit here. I could rotate it and then dilate it, and I would have a figure that was the same shape, just a different size. In fact, let me see if I can make a center of dilation here that'll work for me. So I'm going to pass that through there. I'm going to try and make it twice as big. Just eyeballing this. I have to eyeball a little bit better. I know I need to come up with a right triangle. It's not the best right triangle in the world, but let's just be forgiving and pretend that that worked out beautifully. So this green A prime, B prime, C prime. Is that how it worked out? Oh gosh, no. Nope. Sorry, this is A, B prime, and C prime here. Apologize, that's kind of a mess. But there were two transformations that happened. Let's describe them over here where it says facts and characteristics. If triangle ABC is rotated around point B, no, is rotated around point A, then dilated with, you know what, I should probably give this a name, with center point D. Then it will fit exactly over my finished figure. And they're similar. A prime, B prime, C prime. After that dilation, the pink will fit perfectly over the green. Okay. And in your homework tonight, you're going to be asked to draw some similar figures. So I want to just clue you in to how this is going to have to be. If you've got similar figures, it would not be an example if this were one unit long and this were 3. If I wanted a similar figure, I would need a scale factor to connect these two. If it were an example, let's say I multiplied this number by 4 and got 4, and multiplied this number by 4 and got 12. Something that was 4 by 12 would be an example. But something that was 4 by 9, there's no common scale factor between the short sides and the long sides. Four divided by 1 is 4. 9 divided by 3 is 3. That's not the same scale factor. So how can you check to see if two figures are similar? If you can make them, if you can fit them on top of each other through rigid transformations and dilations. And dilations. All right, so that's our introduction to dilations and similar figures, and hopefully you'll know what it means for two figures to be similar as you work through the homework tonight.